So what is a function? So a function, as we define it here, is a rule that assigns to every element of a set, and that's very important, that every element is very important. To every element of a set called its domain, an unique element of another set, unique element is also very important, one and only one element of another set B, which is called its range or codomain. So a function is made up of three things: the rule, the domain, and the range. The rule must be defined on every element in the domain, and for every element in the domain, it will produce a unique output. That means one and only one output. So if you are looking at f of r plus 2r, f of x is equal to square root of x. This is not a function. Why? Because f of 4 is plus minus 2. If you look at, then fx is equal to positive square root of x is a function. Similarly, fx is equal to minus square root of x. So when we write fx is equal to square root of x, and it is a function, we mean positive square root of x. So that's the implicit understanding. So first note that we can think of the function as a subset of a cross b. And this is the way we think of it, that we look at it as a comma b, where a comes from the domain and b is equal to f of a lies in the range of the codomain. Another way of sort of saying that this is a function is to say that every element of A occurs exactly once as the first element in the ordered pairs in F. So if you're thinking in terms of representing this as a subset of A cross B, then that subset will have the property that every element of A would occur exactly once as the first element in the ordered pair set. Now, there are three basic kind of functions which are very important in math. One is known as one-one function. One-one function means that two different points are mapped to two different elements. Okay, so if you are looking at ABC and you are looking at EFG, GH, and if it happens that you have a relationship like this is a one-to-one function. And if you write it in the set theoretic language, so you see that every element in the domain occurs exactly once as the first element of this subset of A cross B. And also you see that all the elements in the second element of the pair, the second coordinate, these are all unique. So for a one-one function, so one-one function also known as an injection. So one way of writing it is that if FA is equal to FB, then A is equal to. That is one way to express this. Another way to express this is that if A not equal to B, then FA is. And both these are used while solving or while working. Both of these formulations can be used. So these are two equivalent ways of showing one. Another kind of function that is very important is known as onto function or a surjection. Now, for an onto function, the range is exhaustive. Then this function, which exhausts the range, is a onto function. However, if you have this function is not onto, because there are elements G and H which are not mapped. How do you show onto? To show onto, we have to do like that. For every element small b in capital B, there is an element in the domain such that A is equal to 2. So if a function is 1, 1 and onto, so these are called the bijection or 1, 1 correspondence. 1, 1, that means it's an injection as well as a surjection, then it is a 1, 1 correspondence. So to summarize, we say that if second elements of the ordered pairs in the function f are all distinct, then we say that the function is 1, 1 or injective. If all the elements of B appear at least once at the second element of the ordered pairs in the function f, which is the subset of A cross B, then we say that F is onto or surjective or surjective. And if a function is both 1, 1 and onto, then we call it a bijective or 1, 1 correspondence. So in 1, 1 correspondence, if we view it as a subset of A cross B, all the elements of A appears exactly once as the first coordinate or the first element of the pair, and all the elements of B appears exactly once as the second element of the pair,